All right, so we're going to take a look at 7.3, which is using your graphing calculator to solve our system of linear equations. This is particularly helpful when we have large numbers. So our graph would have to be really big, and our scale, we may not be able to pick out that it was 73 on a scale that goes up by 25s. Or a graph that may have a fractional answer. So maybe the answer is 5/3 for an x value, and that's really tricky to see on a handmade graph. So using our graphing calculator could be helpful in that capacity. So I'm going to look at the example that's posted in the textbook for 7.3. Leah's school had a carnival to celebrate Festival de Voyageur. The school raised $1,518.75 by charging an adult $3.75 and a student $2.50. The total attendance was 520. How many adults and how many students attended? So that's our scenario we'll look at, and we'll use our graphing calculator to solve. So write a linear system to model this situation. Well, I can see that we may need to figure out the number of adults and the number of students attending the carnival. So let's say let A represent the number of adults and let S represent the number of students. So in our information here, we were given information about cost and total profit. So if we said that $3.75 times the number of adults plus $2.50 times the number of students, this should give us the total amount raised there. The attendance was 520, therefore the number of adults plus the number of students is 520 people altogether. Now we're going to express each equation in slope-intercept form. And the reason is when we put our information for our equations into our calculator is set up to accept it as a y equals. So what we're going to look at is probably a y equals mx plus b format. So the thing is, looking at our data here, we have a's and s's, not y's and x's. And it doesn't actually matter what you determine is x and what you determine is y. You just need to stay consistent. So let's let a be equivalent to an x variable in this case, and let's let s be equivalent to the y variable. So when we write our equation, we would be looking at it as s equals ma plus b. So let's get s by itself in this equation. That means that we need to subtract 375 from each side. So minus 375a and minus 375a. I'm going to get 250s is equal to 151875 minus 375a. It doesn't really matter of the order here. I know that this is technically b and this is our mx, but it's not a big deal when we're putting it into our calculator. Our last step to get s by itself is to divide both sides by 250. Oopsie. So s is equal to our 1,118.75 divided by 250. You don't actually have to simplify any further. You would just need to make sure that you've actually put brackets around this, our numerator, when we put it into our calculator. But I'm just going to solve because it does work out to a nice number. If it was a gross number, I would just leave it as our fraction to stay exact. Okay, so this is the equation we can put into our calculator, and it will look like y is equal to 607.5 minus 1.5x. Now, to get this equation, where s is by itself, we just need to subtract a from both sides. So s is equal to 520 minus a. So when we put this in our calculator, it'll look like y is equal to 520 minus x. All right, so using my graphing calculator app, I am going to graph this. So you're going to click the y equals button up at the top right. Oh, sorry, top left, my mistake. And that should bring up our y equals. If you have something here, you can just press the clear button and that will clear each of the y formats. Okay, so we said our first one was y is equal to 607.5, and now we need to use x. X is under my alpha key. On yours, it's in pretty much the same position. It's next to the alpha key and below the mode key. It says X, T, theta, and N. So 607.5x minus 1. Oh, sorry, there was no x there. My mistake. 607.5 minus, 1.5x. Again, we use x as our variable. We don't get to use any of the letters within the calculator here, so they have to be in the y and x format. All right, our second one was 520 minus x. And once we have our two equations entered, we're going to hit graph, so the top right button. Now, my graph, like yours probably, is set to a 10 by 10 grid, and I don't see my lines here. They are plotted. What this is telling us is that 10 by 10 is not showing our information. So we're going to go to Window. Sorry, oops, I pressed the wrong button here. I don't know how to exit. Okay, back to my graph, Window. So X, remember, represents the number of adults. The number of adults cannot be negative, so we can at least let this be 0. And let's go to X maximum here of 100. And I'll set my X scale to 10. Again, our Y minimum could also be 0 because Y represents the number of students. Let's put our Y maximum of 100 and our scale of 10 again. And let's hit graph one more time and it'll apply these dimensions. And once again, we still don't see our graph. So I did a little bit more digging after I had just kind of guessed, I guess. I don't want to make my graph super big because then my axis is really large, because then my graph might be in one small corner. So I want to go up incrementally and I want to be smart about this. I don't want to spend my whole day looking for the correct window to see my graph. So I looked at our equations, and remembering that they're in y equals mx plus b format, in s is equal to 607.5 minus 1.5a, 607.5 is the y-intercept. So I need to go up to at least 607.5 in the y direction. So I'm going to go to my y maximum, and let's say 750 is what I want to go up to. So that gives me some leeway, just in case, and I'm going to reset my scale to 50. You want your scale to be something reasonable, otherwise it'll just be a really thick line of ticks denoting the increments. All right, my X max, at this point, I don't know what it needs to be, but I'm just going to guess 500. So again, going a little bit larger and setting my scale to 50. All right, fingers crossed here. Let's hit graph. And when we do that, I can see both my y1 and y2 equations. So our first equation is blue on my screen and our second equation is red. So I can see that they intersect one another, which is great. I need to be able to see that point to do our next step. All right, we've graphed them. Let's head back to our notes here. So we graphed each line. Yay. Determine the coordinates of the point or intersection of the lines. Are these coordinates exact or approximate, and explain. So heading back to our graph, if we look at this intersection, remembering that my scales were going up by increments of 50, in the x, it appears to be, I don't know, 50, 100, 150, between 150 and 200, so maybe 175. And then in the y direction, it's 50, 100, 150, 253, somewhere between 3 and 350. Mine, obviously, we can kind of move around because it's on my iPad. You would have to trace on yours, and it'll allow you to move your cursor around if you wanted to kind of approximate. All right, you don't need to do that though, because our graphing calculator can do this all for us. We are going to calculate. So you're going to use your second and you're going to hit trace, because above that it says calc. We're going to use the calculation function. So second calc, and we're going to calculate an intersect, where our lines intersect. So you can either tab down and hit enter or just select 5 from the menu. All right, and ours is asking, are you on the first curve? It doesn't actually matter. I can't even really tab over because it goes so slow. But you could move your cursor around using the left and right buttons on your calculator to see if it is in fact on a line. You can trust that it is. So you're going to hit enter, and then the cursor will jump to the second line, and it asks, is the cursor on the second line? Question mark. And you can say yes, enter, it is. Then it's going to ask you for a guess. You don't need to do this at all. Just keep on pressing enter. So basically, you can say intersect and hit your enter button 3 times, and it's going to spit out an answer. It says x equals 175 and y equals 345. So those are the coordinates where our two lines intersect one another. So let's head back. Determine the coordinates. Remember, our coordinates are x, y. So we're going to write 175, 345 is the solution. Are these coordinates exact or approximate? Well, because they're a whole number, there's no decimal. These are exact. If it was something like 3.3333 repeating here, that would be an approximation. And if it was something like 4.341732 ... that's obviously another approximation of an irrational number. So that might be a little bit more tricky. I can't remember if our calculator spits out a fraction or not. I think it just gives us decimals. So we're going to look at other methods. If we get an irrational number here, to get an exact value of, I don't know, like 14/3, whatever it was, to give us this number later on in calculations. So it's our calculator is great for exact coordinates. It might not be as helpful if we were asked for an exact answer, which is not a decimal, but rather the fraction. How could you verify the solution? By using tables of values. So let's head back to our calculator screen for a second here. If you select shift or second, graph, which is table, it should show a table of x and y values. So this is x values for both, and then what the y value would be for that x calculation. And you can see that we could scroll all day through these values to find where y1 and y2 have the same y value. So we know that that was at approximately x equals 175, I think. So we have to scroll through, carefully looking at our table of values to find where both y1 and y2 have the same value for that value of x. So when x was 175, y1 equals 345, and y2 equals 345. So when those two values are identical, that is where they have intersected on our graph. I don't find the table of values very helpful, but it is something we could use if we were struggling with our graph. Verify your solution by using the data given in the problem. So I think what this is asking is for us to check our work. So we knew that x was representing a, which was 175, and y was representing s, which was 345. We had two equations. Our first one was we should write our original, not our manipulated, because what if we made a mistake when we were manipulating our equation? So we're going to use our original. Plus 250 s equals 151.875. I mean, you could use your manipulated version if you really trust your mathematical abilities, and I hope you do, but it's always good practice to just use what's in the question so there's no error. Subbing in what we know, we have 375. I meant to sub in my value for a here. 175 plus 250, 345 equals 1518.75. All right, 375 times 175. I get 656.25. And 862.5 equals 1518.75. Now if we add these two together, the left side is 1518.75, and our right side is still the same number. Because the left side equals the right side, looks good. Then we had a plus s is equal to 520. So 175 plus 345 equals 520. 520 equals 520. We are good. Okay, so we could check using our steady method there of just subbing into both equations. All right, how can you use your results to determine the number of adults and the number of students who attended the carnival? I think we've kind of answered this because we knew that a was equal to x, which is 175, and s was equal to y, which equals 345. So the number of adults was 175, and the number of students was 345.